Welcome back, chemistry fans. We are going to today take you through Unit 5, Topic 5 notes, and this is going to deal with covalent molecules, to which you're saying, what's the difference between a covalent molecule and any other molecule? Well, the other molecules we've been dealing with are called ionic compounds, ionic molecules. And so we got to try and figure out how to distinguish them. So let's jump right into the notes so that you can start learning this process. Then we'll worry about the naming. What's most important that you should realize about these are that both elements in these binary compounds are going to be non-metals. So in the ionic compounds, what we had was a metal and a non-metal, but all of these elements are going to find themselves on the periodic table on the right side. So let's take a quick look just to remind you what we're talking about, where we would find those elements. So if we look over here on the right side of your periodic table, we are seeing that these elements are over here on the right side of this staircase. So everything to the left over here, these are your metals. And then over here to the right, there's quite a few less of the number of nonmetals, and these are all on the right side. So we're talking the carbons, the phosphorus, nitrogens, oxygens, fluorines, chlorines, bromines, iodines, all of those are nonmetals. So those are the only ones that we're going to deal with. Now, because there is all negatively charged particles, well, we had to come up with a different naming routine. And that's what we're going to have to deal with, is the fact that they no longer going to crisscross applesauce. They're no longer going to share their charges or exchange charges. What in fact they're going to do is share their electrons. The electrons are going to be in both places at the same time. So what you will notice over here on the right side is that this one red electron is moving locations. It now finds a new home on the negatively charged ion, and it creates a positively charged ion on the left when it loses an electron. They still achieve stable octets, and that's the ionic bonds. What we're going to talk about are covalent. What happens is they will decide to share the electrons at the same time. So these electrons will find their way on both of the molecules. Some of them are going to be on the left at some point, and then some of them are also going to be over here on the right. So it's like they will figure out a figure eight. They will go around both atoms, creating a bond in between them, not because of a difference in their positive and negative charges, but because they are continuously circling around both atoms. These are called covalent molecules, covalent bonds. So again, just looking at this, if we have two nonmetals, we will notice that they neither one on the left have a stable octet. They will achieve a stable octet by sharing each electrons that they have available as unpaired. So these are going to share together, and they will make their way around as a stable octet going in a figure eight motion. Convenient that it makes that type of image. Now, how we can represent this with something we've talked about before is through the orbital diagrams. And what you'll notice is that this first element up here, it is hydrogen. This down here is fluorine. Hydrogen has 1 electron, fluorine has 9. So I'm representing all 9 electrons, but neither one of them have stable octets. So what they will do is they will share the electrons in between them, and we will represent this with just simply a dash in between the two atoms, in between the two symbols. And so what happens is this electron finds its way down to the fluorine, and at the same time, the fluorine is going to share its electron with the hydrogen. Remember that these electrons are moving in close to the speed of light, so it is realistic for us to imagine that these electrons are in both places at the same time, because we would blink and it would look like they were in both places. So on these fluorines, if they wanted to share with one another, what they would do is they would put their electrons in each other's position, and we could represent it that they are sharing their electrons. That's called a single bond. Now, what if, though, we happen to want to find a place where 2 electrons could share? That's also possible. So these electrons will share, and these electrons will share, And what we would represent here is a double bond showing two dashes in between them. And if we wanted a triple bond, that is also entirely possible. Okay, now, because we've established that there is a new way in which these atoms are bonding, we need to come up with a new naming routine. And that is going to encompass now adding prefixes. The most common mistake that novice chemistry students will do is that they will now want to apply prefixes to every single molecule. You must pay attention to the fact that the first element is not a metal. It is a non-metal. And therefore, when they are both non-metals, you are going to have to use this new naming routine with prefixes. The prefixes are representative of the number of atoms. So in other words, di means that there are 2 nitrogens. Tri means that there are 3 oxygens. You do not reduce these charges because there is no crisscross. The 2 is the number of atoms, and therefore it must be represented with a prefix of di. Now, because it's binary, however, we are going to use the same naming routine with a suffix of IDE. Now, here are your 10 possible prefixes that I need you to write down and to memorize. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca, representing the 1 through 10. Now we are ready to try our best to come up with the names of these molecules. Do not reduce them. Hexa is for 6, so this will be hexa phosphorus. Now notice phosphorus. Notice I did not put a suffix on the first one. It's hexaphosphorus tetraoxide. The suffix only goes on the second one, but prefixes go on both of them. So I've got next difluorine, no change in the suffix. Pentaselenide, IDE. The prefixes are used for the number of atoms. The IDE is the suffix. Now this last one, it is challenging in that you're going to want to put a mono, but every one of us should recognize what this molecule is, CO2. This is carbon dioxide. We should not need to put a mono. If you put a mono in there, it's just the same as if you put H2O1. We don't put a 1 for the water molecule. It's understood that if it's written that there is one of them. However, it's inconsistent because if we have CO, that name would be carbon monoxide. So there is some inconsistencies with the way in which we name them. A second inconsistency that I'm bringing to light here is the fact that many times we will cut off the last vowel in the prefixes if the element starts with a vowel. So in other words, if I were to do triiodine, I don't put 2 i's together. It just becomes triodine. Or if I were to have octaoxide, I don't put the A in there. It becomes octoxide. So we cut off that last vowel whenever we have a vowel for our element's name. I'm never going to count you wrong on the spelling. These are just little details that I'm making you aware of. Nice to know things, but not necessary to know. Now, the last one is a trick. Why do we not use prefixes with this one? Well, you should recognize that calcium is a metal. So the name of this one is calcium bromide. It only has the suffix. There are no prefixes because it is a metal, non-metal. It did a crisscross applesauce and its charges were exchanged. It is an ionic compound. It is not covalent. All right, for our last one, here's that carbon monoxide. We have to understand that there is a 1-to-1, but because they are ones, we don't need to write them. Diphosphorus decachloride. Now, this one would be tempting to reduce down to 1 and 5, but because it is a covalent molecule, we do not do any reductions. This is the number of atoms that would be possible. Dinitrogen is 2, and tetroxide, there's where we have that cutoff of the vowel, it should be tetraoxide, but because oxygen is a vowel itself, they do not combine the two vowels together. So it's tetroxide. So that's N2O4. All right, this is everything that I wish to share with you about the nomenclature of covalent molecules. Hopefully, with some practice, you're going to get better with it. And do not now start using prefixes on everything. Only use it if both elements are non-metals. Thank you so much for your time. I will talk with you again soon. Farewell.